Hi, Khaled. He's a new friend. Hi, Khaled. Can you hear me? Dipinto. Hmm? Cuman gue di sini saya mau itu pada jadi saya बहुत पाइछु
Tony, আমি চাৰিটাত start কৰি দিম না, যিমান আহি থাকে আৰু পিছত সোমাই থাকিব।
हेलो, हरे कृष्णा। हाँ हाँ, मैं ठीक हूँ। अभी मैं एक ऑनलाइन वेबिनार में हूँ। ओके, you may ring me in the evening. Okay, after say 7:30. Okay. हाँ जी. Yeah. Please send me the link. Okay. It will just be started from 4 o'clock. I have a speech to make. Okay. So we'll talk later on. Thank you so much.
Yeah, Harry. এটা প্ৰিন্সিপালে হেৰি ক'ব।
Very good afternoon to all of you. Am I audible?
Yes, ma'am.
Am I audible? Okay. A very good afternoon to all of you. I welcome you all to the national webinar on application of SPSS in social science, which is organized by the Department of Mathematics and Statistics of K.C.Das Commerce College. In these difficult times during the pandemic, K.C.Das Commerce College has taken several initiatives to keep the academic pursuits flowing, which is possible primarily due to the cooperation and support of our principal, Dr. Rishikesh Borua. The topic of today's webinar is very much pertinent for statistical analysis of data. As we all know, the statistical package for social sciences, popularly known as SPSS, is a versatile and responsive program which is designed to undertake a range of statistical procedures. Though SPS is used for all kinds of research, but today we have limited our discussions to social science, where SPSS is applied profusely. Now we are indeed very pleased to have amidst us Dr. Manas Pratim Bormon, Associate Professor, Department of Statistics, Dibrugarh University. He is well versed with the statistical software SPSS, so we can have a good insight on how to use the software or the statistical package after his deliberations. With this, I once again welcome you to this virtual gathering. Now, may I request Dr. Rishikesh Borua, Principal, K.C.Das Commerce College, to deliver his inaugural speech. Over to you, sir.
Thank you. By the way, am I audible?
Yes, sir.
Okay. Respected speaker of today's webinar, Dr. Manas Pratim Bormon from the Department of Statistics, Dibrugarh University, Dr. Runjun Phukon, Head of the Department of Mathematics and Statistics, K.C.Das Commerce College, esteemed colleagues, namaskar, and a very good afternoon to all of you. On behalf of K.C.Das Commerce College, at the very outset, I welcome all of you to this virtual arena where we will be enlightened on the theme, application of SPSS in social science research by Dr. Manas Pratim Bormon. Dear all, nobody thought that the year 2020 will make us change gears so fast in order to cope up with the changing situations. Human interference with different ecosystems has remained unabated. And as on today, nearly 195 lakhs of people have been affected globally. In India, the figures are nearing 21 lakhs, while in Assam, it is more than 52,000. Now, coronavirus is in the community spread stage. There are several websites which helps us to understand the spread of this virus daily. One of the popular such website is a Worldometer website, which shows updates on coronavirus country-wise daily. And I believe almost all of us visit such websites of similar nature. Now, the fact is that as we open such websites, we see pages full of numbers, graphs, etc., under different heads, like say total cases, new cases, total deaths, recovered, active, serious, critical, etc., etc. Now, just a while ago, I also went through that particular page, and I just wanted to see that, well, let me check what is the recovery rate. And then what I could gather is that as on today, the recovery rate of the top 3 countries are such that USA, it is 51.36%. Brazil in the second spot is having 69.71%. India in the third is having 68.33%. And surprisingly, the whole world says that China, Wuhan, has been the epicenter from where the coronavirus has spread. And there, the recovery rate has gone to 93.5%. And today I took a screenshot, just a screenshot to so that I can check in future, because over the last few days, I have not seen China's number increasing. Now, my point is that these numbers, their permutations and combinations, statistically helps us or helps one to have a pragmatic understanding of the ground reality and the necessary steps that has to be taken, since this particular virus, if we talk in this particular context, this particular virus is a novel one and it has no historical medical database. As such statistical outputs can have serious impacts on any field, be it health, economy, education, or even in the mental health of common people. Well, that apart, there are various statistical softwares which helps people, or research scientists in particular, to have data analyzed. SPSS, or popularly known as SPSS, and that's a statistical package for the social science, I believe was created for the management and statistical analysis of social science data. But so far I know this package is used in various disciplines. In fact, I personally have used a little bit of this this particular software in my geological researches. Ladies and gentlemen, creation of data have been a logical consequence of mankind's cerebral and technological advancements. As on today, data management is in fact one of the biggest priorities and greatest challenges, right from the national or corporate to individual level. However, data in itself is of no value, I believe, if one cannot play with them and figure out their intrinsic attributes. SPSS is one of the most popular softwares, mainly used by research scientists globally to process critical data in simple steps. The same set of data can be utilized to generate more and more intrinsic attributes and interpretation, depending upon whether the analysis is univariate, bivariate, or multivariate. There is a popular quote, if you all don't mind, the statistics people. There is a very popular quote which says, lies, damn lies, and statistics, which describes the persuasive power of numbers and particularly the use of statistics to bolster weak arguments. It is also sometimes colloquially used to doubt statistics and used to prove an opponent's point. Now, authenticity of the tests and observations, proper sampling, and type of sampling techniques utilized, depending upon the objective of the work, standard of input data, etc., are very important factors as the statistical output depends on these. One of the most important uses of data analysis, I believe, is that it keeps or it helps human bias away from research conclusion with the help of proper statistical treatment. If procedural lapses occur, the statistical output becomes redundant. And in this regard, I believe tenacity and perseverance of the research scholar is a very important factor. I am a layman, I cannot say much more than this, but I believe that after today's webinar, we all will be highly gained on the use of SPSS and its various attributes, which we have never known so far. And I'm very happy that we have amidst us a person who is well known for his research work in this particular field. I once again welcome Dr. Borman to our virtual arena, and I sincerely hope that in near future we can also have him physically amidst us. So with these few words, I would like to sum up my speech. So best wishes to everyone. Thank you so much. Over to you, Runjan Baidu.
Thank you so much, sir, for your well-articulated and informative speech. Now, without much ado, we move ahead to the main agenda. Prior to that, I would like to request Dr. Chandana Goswami, Assistant Professor, Department of Mathematics and Statistics, to present a brief introduction of our resource person. Over to Chandana.
Hello. Am I audible?
Yes.
Am I audible?
Yes, you're audible.
Good afternoon to everyone. I have the proud privilege to introduce our today's resource person, Dr. Manas Pratim Borman. He graduated from Dibrugarh University with major in statistics in 2000. In 2003, he completed his MSc from the same university. Following that, in 2005, he completed postgraduate diploma course in computer application from Sikkim Manipal University. He did the course of Master of Population Study in 2008 from International Institute for Population Science. He did his PhD from the Dibrugarh University on analysis and quality of life, statistical study of stomach and esophagus cancer patients in Northeast India in the year 2009. He initially joined in the Regional Medical Research Centre, Northeast Region, ICMR at Dibrugarh in 2003. Then he joined in Dibrugarh University as an assistant professor of statistics in 2007. Presently, he is an associate professor in the same university from 2019. He had published 31 papers in various national and international journals. He had contributed chapters as 7 edited books. Under his guidance, 7 students were awarded MPhil degree and 1 is still pursuing. He is presently guiding 5 PhD scholars. Also, he has done 2 research projects. He specializes on statistical softwares like SPSS, Statistica, R, NGSS, EASS, EP-Info, C.S.T.A.S, MATLAB, and RDSET, etc. Hope we will be highly benefited from his presentation. Thank you. Over to Vaidu.
Now I request the participants to type their questions, doubts, comments in the chat box, which will be addressed by the resource person after the end of the presentation. Okay, now I request Dr. Manos Pratim Burman to kindly take over.
Thank you, Baidu. Am I audible?
Yes, yes, you're audible.
First of all, I want to offer my thanks to the K.C.Das Commerce College fraternity for inviting me, and also the principal of the college for inviting me to deliver a lecture on this topic. And I also want to thank one participant. He's Khalid Almagri. He's all the way from he has joined all the way from Palestine. He is my friend. Thank you, Khalid, for considering as a participant. Okay, now let us start. So today I'll be talking on application of SPSS in social science research. SPSS, initially the full form of SPSS was Statistical Packages for Social Sciences. But now actually all the sciences, students from all the sciences is using statistics. So it is no longer as Statistical Packages for Social Sciences. It is renamed as Statistical Product and Service Solution right now. And it is now purchased by IBM. Okay. Now, before going to SPSS, I want to mention softwares. First of all, I have to mention some basic statistical software, that is MS Excel. MS Excel, I think everybody knows about MS Excel. MS Excel is a very powerful statistical tool. We can do a lot of statistical calculation in MS Excel. We can do inferential statistics as well as descriptive statistics in Excel. And it has a lot of options for graphical presentations also. Then we have SPSS, then EP-Info. EP-Info is a free software. You can freely download it from the internet. And one of the disadvantages of SPSS is that for analyzing with the help of SPSS, you need to have individual data set. Suppose a lot of people came to me actually with with 2 means. They don't have the individual data of human individual. They have the means and standard deviation. They want to analyze the data. In that type of situation, we cannot use SPSS. So for that type of situation, EP-Info is a perfect software with the help of which we can do calculation where we don't have individual data. Suppose we have only the means of 2 groups, means and standard deviation. We don't have the individual data. So in that case, you cannot apply SPSS. You have to apply EP-Info. Then Stata and Minitab, these are not free software. And a lot of these are actually equivalent to SPSS, but it is not free. And in Stata, we have a lot of statistical options are available. Then R is now very popular. I think everybody knows about R. It is also free. R MATLAB is also very powerful mathematical tool. Then Python is used for doing statistical analysis also, and it can be used for a lot of purposes. For suppose web designing like this. Python is also nowadays it is very popular. Okay, now let's come to my topic. suppose I am basically doing my research in medical statistics, biostatistics. So my the data I am going to show you is based on health related data. Suppose to use SPSS to do any study, first of all we need to have some, we need to have some objective. We need to have some objective with the help of which we are going to achieve the objectives through data, by collecting data. So let us have a study. Suppose we are going to conduct a study on prevalence of hypertension and its associated factors. Suppose I want to conduct a study in Guwahati to study the prevalence. What is the proportion of people are infected from the disease hypertension? So I want to know that proportion. What is the percentage of people infected from hypertension in Guwahati, and what are the factors that is associated with the disease. So these are my objective, to study the prevalence of hypertension in a particular community. Suppose we are going to study it in Guwahati. Then second objective, to study the influence of different factors such as age, sex, place of residence, education, body mass index on hypertension. So how this variable, these factors, these age, sex, these factors influence the blood pressure in a individuals. Okay, so I want to my two objectives are two. First of all, I want to see uh, what proportion of people are infected from the disease in the community in Guwahati city, and second one is what are the factors which are responsible for this blood pressure. Okay, so for that, first of all, I need to construct a questionnaire. Okay, so let us construct a questionnaire. So data may be primary or secondary. So we can collect it from the secondary source also, or from primary source also. So suppose for this type of study, we can use National Family Health Survey data. In National Family Health Survey data, we have a lot of information on blood pressure, hypertension like this. So let us suppose we are doing a primary survey. We are going to go to the household and collect the information. So for that, I need a questionnaire. So this is the questionnaire. Suppose first of all, I'll collect the name of the respondent, then residential status. He's from rural area or urban area. Then age of the respondent, then sex of the respondent, male or female, then education, illiterate. These are the categories I have made. Okay. Then type of work, that what type of work the person is engaged. It is sedentary, active, or heavy. Okay. Then extrasol. Extrasol is why I'm taking this point, because it is believed that if we consume extrasol, if we consume extrasol, then there is a more probability of hypertension. So I am also taking these variables. Then family history, then height, weight. These are the variables. These are the information that we are going to collect from the questionnaire with the help of this questionnaire. Okay. So suppose this is a fill-up questionnaire. So we go to the field and collect the information. Suppose this is a fill-up questionnaire. Name of the respondent. This is the name. Then he's from rural area. His age is 46 years. He's female. She's female. Her education is graduation. Suppose his type of work is suppose active. Then his family history. Suppose yes. That means his father or mother is already infected from the disease. His height is 4.5 meters. His weight is like this. The systolic blood pressure is like this. So I think everybody knows that there are two readings for systolic blood pressure. One is for blood pressure. One is systolic, one is diastolic. So we have to take two readings. One is 134. For systolic, it is 137. For diastolic, it is 85. So we have to take two readings: systolic blood pressure or diastolic blood pressure. Okay. So this is a filled-up questionnaire. Okay. Now we suppose by using a sample size calculation formula, we calculate the sample size as 300. Okay. So I have to go to the 300 individuals selected randomly. We have random sampling is very important. That is not the topic for today's discussion. So I am not going to talk about sampling, but sampling is very important. Otherwise, you are not going to get a fruitful result. Okay. So suppose we have calculated a sample size of 300 individuals, and we we selected this 300 individual by going to the randomly selected households and collected it in this information. Okay, now you see these are some of the information. Suppose I have arranged the data. Okay, so first name of the respondent. This is the name of the respondent of the first individual. This is the name of the respondent of the second individual, and this is the residential status. This is the age. This is the sex. This is the primary education, like this. Okay, so these are the name of the respondent. So let us arrange this data like this. Now you see here, this first variable name of the respondent, I think we don't have to do anything with this. Okay, so the name, we cannot do any analysis with name in statistics. Okay, now residential status, age, sex, education, these are some important variables. Now residential status, sex, education, these are qualitative data. Nah? It is not quantitative, but statistics cannot deal with qualitative data, right? Statistics cannot handle the qualitative data. Okay, but these are qualitative data. So what do I have to do? Should we ignore this data? If we ignore this data, then lot of information will be lost. Okay, so we cannot ignore this data. So only age is quantitative. So for age we have no problem. We can use this age to do the statistical analysis. But for other variables, we cannot use statistical analysis because they are qualitative. Okay. So what we do, but also we cannot ignore them, because if we ignore them, we'll have to lose a lot of information. So what we do, we make them numeric by assigning numerical codes. Okay, this variable residential status is, we call a categorical variable. Why? Because the responses are in two categories. The responses given by the individuals have only two categories, either rural or urban. Two categories, rural or urban. So it's a categorical variable. Sex is also a categorical variable. The responses given, if I asked a person about his sex, so he will answer either male or female. So these are two categories. Okay, then same way education is also a categorical variable. So what we do, we converted them to numeric values. We give numerical codes to them so that they can be analyzed. Okay, so what we do, we give numerical codes to these categories so that can be analyzed statistically, right? So what we do, we converted them by giving numerical codes. So let us make a code book. This is called a code book. Okay, by using this code book, we can give, this is very important. Okay, so you should make a code book always like this. Okay, so I have given code rural is equal to 0, urban is equal to 1. Then you can give any code. You can give 100 to rural, 101 to urban, no problem. But if you give 0 and 1, there are certain advantages are there. Okay, I'm not going to discuss because it will take a lot of time. I'm not, if you give, you know one thing, that if you give 0 and 1, as when you have two categories only, then you should give 0 and 1. That will have lot of benefits. Okay, if time permits, I'll show one of the benefits. So age of the respondent, then sex, I have given male 0, female 1. Then education, I have given illiterate 1, primary 2, SSLC 3, SS 4, like this. Then type of work, sedentary 1, active 2, heavy 3. Then extrasol, yes for 1, no for 0. So I make all the categorical variables numerical by assigning numerical codes. Now it can be analyzed statistically. Okay, now variables. So in the questionnaire, you see these are called variables. In statistical language, we call them variables. Residence status is a variable, age is a variable, sex is a, why it is variable? Because in simple language, it varies every time. Now for individual to individual, it varies. Some says my age is 24 years, some says my age is 35 years, like this. So individual to individual, it varies. So we call in statistics, call it has different example diagrams also, but in simple way we can say like this. Okay, so variables, so there are two type of variables we have in our questionnaire. one is discrete variable, one is continuous variable. Okay, so who are discrete variables? So discrete means discrete. You see in this variable, originally this residential status is a qualitative variable, but we make them quantitative by assigning both 0 and 1. This variable only gives responses only in 0 and 1. Okay, it gives values in only integers. Okay, so that's why this type of variable is called discrete. It cannot give decimal values. Okay, to be more precise, it cannot give us decimal values. Okay, suppose 0 or 1. He may be from rural area or he may be from urban area, 0 or 1. It cannot give 0.5 like this type of values. So these values are called discrete variables. Okay, so sex can take decimal values. No? So sex is not a discrete variable, it can continuous. Step. Suppose I asked one person about his age, so he said that my age is 26 years. Most of the people rounded up their ages. Actually, they don't respond their actual ages. They don't give their actual ages. It is not also possible also. Suppose his actual age maybe 26 years, 5 months, 3 days, 1 hour. If we put this like this, then it will come in a decimal places. So it's a continuous variable. So sex is also a discrete variable. Education is also a discrete variable. Then type of work is also a discrete variable. So weight is not a discrete variable. It is a continuous variable. So continuous variables, because it may comes in decimal places. He may be 54.5 kg. Or his height may be 7.5 inches like this. So these are continuous variables. So there are two types of variable basically. They are discrete and continuous. So residential status is a discrete variable, sex is a discrete variable, education, type of work, extra self, these are all discrete variable, and these are the continuous variable. So discrete variable again divided into two parts. The knowledge of this variable type of variable is very important, because the type of analysis you are going to do will be based on the type of the variable, type of the data, right? So the knowledge of this data types is very important for studying, for doing statistical analysis. So discrete variable is divided into two parts: nominal and ordinal. Nominal is residential status, sex, extra-social, family history, and education and type of work are ordinal. Okay, I'll tell you in very small time. Now, why residential status become nominal? Nominal is the lowest category of the scales of measurement. Okay, the nominal, because there are definitions are there, but I want to tell you a very simple way, that here you see we have given quotes rural to 0 to rural, 1 to urban. Okay, rural to 0, 1 to urban. I have given more values to urban. Does it mean anything that urban people are better than rural people? No, I am giving these codes just to identify. Okay, so when we give codes just to identify, okay, that type of variable is called nominal. So same way, sex, I have male, I have given 1, female, I have given male, I have given 0, female is 1. It does not mean I have given more value. It does not, if I have given more value to females, it does not mean that females are better than males. Okay, I'm giving these codes just to identify. So this type of variables are called nominal. And education is not a nominal, because it is in a particular categories. I cannot put primary education 1 and illiterate 2. Okay, it is just not this is not like our nominal variables. Okay, so here we have to maintain a particular order, because the categories are in a particular order. You see, illiterate, then primary, and then the education goes on increasingly higher education. So we have to maintain a particular order. So this type of variables are called ordinal variable. Okay, then continuous variable. All these continuous variable are ratio scale, and there is no variable which are interval scale. Ratio scale variable means there exists a true 0 point, and interval scale means there does not exist a true 0 points. True does not exist 2 0 point means, that means 0 means not 0. One perfect example of this is a temperature. Okay, temperature, if I say that temperature is 0, it does not mean that there is no temperature. One particular point will be 0, where water freezes, we call it 0. We have assigned that point where water freezes, we call it 0. So suppose age is 0. It means the person does not exist. 0 means 0. But in interval scale, 0 means it does not 0. Okay. So all the these continuous variables falls in the ratio scale. Okay. Then steps in data analysis. Okay. So first of all, after collecting the data, after make them coding, first of all, our purpose is to collect the data. Then we have to make the code book. We have to assign the data in different codes. Then first of all, our purpose is to creating a database and data entry. This is the first step of doing statistical analysis. This is very important. If you don't create the database in a proper way, it will not be easy for you to calculate the data. Okay. Then editing of data. Editing of data is very, very important also. Okay. So editing, without proper editing, you cannot analyze the data properly. So the last point I have given as analysis of data. So these are the steps we have to follow for analyzing the data. Okay, so type of analysis, type of descriptive and inferential. I'll talk talk about it later. First of all, let us go to the SPSS. So for opening SPSS, let us open SPSS. It will take some time actually. I am using SPSS 20 version. I think the latest version is 26 or 27. Okay, it is opening now. So this is IBM SPSS. So this is the first appearance of SPSS. So this small window, it shows the recently used files. Suppose if you want to open some recently used file or recently used file, then you have to click here. Suppose I want to open this file, then I have to click here and click OK. Okay, right now I don't want to open any recently used file, so let us cancel it. So this is the SPSS. This is the window of SPSS. So you see there are different menus are here: file, edit, view. These three menus are same as Excel or any Word, or you can say that Word, this file, edit, and view menus are same as Excel. Okay. Now there are differences from here. There's the important menu called data. Then we have transform, then analyze, then graphs. Actually these are very much used in analyzing data. Okay, data, transform, and analyze. In analyze we have different statistical, lot of variety of statistical methods are available, and in data and transform we can edit our data. I'm repeatedly telling you that editing of data is very, very important. Without proper editing of the data, you are not going to get good results, fruitful results. Okay, so from what the data we have collected is in the raw form. We have to edit the data before doing the proper analysis. So editing of data is done in data and transform menu. Okay, and analysis of the data, in the analysis we have to do lot of statistical analysis, and we have graphs also. So there are a lot of graphs, provision for creating graphs are available here. Okay, now if you go to this left bottom, you see there are two tabs. One is data view, one is variable view. You see data view and variable view here. This one data view and variable view, right? This one data view and variable view. Okay, so let us talk about it right first. Uh, Now in data view, you can see your data. What data you have entered, you can see it in data view. And in variable view, you have to, you can see the variables. So in the questionnaire, the questions are variables now. So we have different questions, residential status, sex, age, these are called variables. So we have to first put the variables in variable view. This is what designing, this is called the designing of the database. Before entering the data, we have to design our database. Okay, so for that, what we have to do, we have to put all the variable names here. So in the, you see here we have to put the variable names. In the first row, we have to put the first variable name, first variable. In the second row, we have to put the second variable. In the third row, we have to put the third variable. In the fourth row, we have to put the fourth variable like this. And in the columns, we have to put the different characteristics of the variable. This is very important. In the columns, we have to put the different characteristics. So this is the, first of all, we have to give a name of the variable, first variable. Then we have to give the type, what type of data we are going to enter. We have to specify that one. What is the length of the variable? What is the length of the data we are going to enter? Then level. So I will show you how to make the design the database. Okay. So our first question is name of the respondent. Okay. So first of all, we have the first variable is that our name of the respondent. Okay, this one, name of the respondent. So first variable we have to enter here is the name of the respondent. Okay. Okay. So here I have to put the name of the respondent. So first of all, I have to give a name of the variable. Okay. So in SPSS, you have to follow certain rules to give the name of the variables. Okay. I'll show you what rules you have to follow for giving the name of the variable. First of all, I have to give a name of the variable. So these are the rules with the help of which we have to give the name of the variable. So first rule is that in SPSS version 12 or later, a variable name can have maximum 64 characters. Okay. So characters made up of letters or numbers. Okay. So in we have to, in SPSS version 12 or later, we can give variable name up to 64 characters, and which can be made up of letters and numbers. Okay. Okay. So for this is the first rule. Then a variable name must begin with a letter or this character. Okay. So variable name must begin with a letter or this character. So variable name cannot start from a number. So I'll show you. Suppose I have to give the first variable name. Okay. So this is the here. The first variable is name of the respondent. Suppose I give one. One is the question number one. One means question number one. Okay. So I give one. Okay. So if I put like this, so you see what information it will give. Variable name contains an illegal first character. So as I have given a number in the first place, it will not take it. So it will be an illegal character. Okay. Variable name contains an illegal character. So it cannot be, variable name cannot be started with a number. Okay. Or it can start with a this letter. Okay, @ 1. Now it will take, you see, it will take as a variable name. Okay. So third rule is that a variable name cannot contain blank spaces. This is very important. And these characters it will not take. Okay. So it cannot contain blank space. The third point is that the variable name cannot contain blank spaces or these special characters. Okay. So uh, suppose I want to give the variable name as name of the respondent, because this is my question, name of the respondent. You can give like this also, no problem. So you see, as I have given space, name space of the respondent. Okay, I have given space na, so it will not take. Variable name contains an illegal character. Okay, so this is an important rule. You cannot give blank spaces while creating a variable name. So variable name must be unique. No other variable in the data file can have the same name. So variable name must be unique. Suppose I have information on age of husband and wife, right? Suppose I have collected information on age of husband and wife. So if I give age of husband as age, okay, so this is the variable name for age, for the variable age for husband, and for wife if I again give age, then it will not take. The variable name duplicates an existing variable name, so it cannot be it must be unique. So for that, suppose I want to put age of wife, then I have to do like this, w for wife. Okay, so this is the third important character. So fourth important point is the variable name must be unique. Okay, no other variable name in the data file can have the same name. Then the period, last point, the period, underscore, and these characters can be used for for creating a variable name. Okay, these characteristics can be used for creating a variable name, right? So these are the points you have to remember while giving the name of a variable, right? Okay, so let us start. Okay, so first my question is name of the respondent. So let us give the variable name as name underscore, because it will not take blank spaces. So I prefer to give underscore instead of blank spaces, respondent. Okay, so this is my first variable name respondent. So then I have to specify the type of data I am going to enter in this type option. So here, what type of data I am going to enter? I am going to enter alphabetical data because it's a name, no? So it's not a number. So I have to change it. So I have to click it here. So you see there are a lot of options are there, numeric, comma, dot. So I have to click on string. String means it's alphabetical. Okay. So here here it will take only 8 characters. You see here 8 characters. So if I want to enter my name, so my name has 16 characters. So if I have only 8 character option is there, so it will take my first 8 characters only. So I want to increase it. So you can very easily increase it. Suppose I want to, now it will include 26 characters, right? So the name, this is the first characteristic, name of the respondent I have given, then type, then width is 26, then level. Level means what? Level is also very important thing. Suppose in name, I can give any shortcut from, suppose Q1 stand for question 1. I can give variable name like this also, Q1. It means question 1. So in level, you can explain what is Q1. Okay. Suppose there is no rules, you can type anything. Suppose name of the respondent. Okay. So now it will be easy for you to understand what is Q1. Okay. So if I go to data view, you see Q1. Now, suppose if you open the database after a long time and you don't have the questionnaire, then you don't understand what is Q1. You may forget it. Okay. Then if I go to variable view and see the label, then it is clearly written here. This question number 1 is nothing but name of the respondents. Okay. Then values is not necessary here because it's an alphabetical variable. Then these things are not necessary because it is an alphabetical variable. Missing columns, these are alignment, these are same thing. It will take 8 values columns, alignment left, right, or it will be same as Excel or Word like this. Then this point is important, values and missing can be used if I want to ignore some data, then we can use the missing option. Okay. So if time permits, I will discuss it later. So this is my first variable Q1, right? Then I have to construct the second variable. Second variable is location, right? I think location was my second variable. So residential status. So residential status is my second variable. So let us give the name of the variable as Q2. Okay. So Q2. Suppose Q2. Now Q2 means the second questions, or I can give like location also. Location means place of residence. Like this also I can give, no problem. But I have to follow the rules that I have already mentioned to give the name of the variable. Okay. Then what is the type of this data? Earlier it was a qualitative data. It has two categories, rural and urban. Now it becomes numerical because we have assigned numeric codes, so it becomes numeric. Okay. Then here residential status. I can explain it. Okay. Now here we have categorical variables with two values, 0 and 1. We have given codes 0 to rural, 1 to urban. Now here in this place in the value we can save the codes. Okay, this is very beneficial. I'll show you later why this is beneficial. So here I can save the codes. Okay, so click here, click 0 for rural. So 0 for rural. Okay, I'll show you one more time. You go there. Now it is a qualitative variable. It has, we have given codes now, so I have to use this coding values option. Then I click here, click. So this window comes here. I have to put the value, and here I have to put the level. So put 0 and level is rural. Enter, and 1 for urban. Click OK. Add 0 for rural, 1 for urban. So you see it save here. Okay. Now there is no missing. Then columns it is alignment, left, right, anything you can give. Then measure. Here I have to specify the scale of measurement. We have already discussed the scales of measurement. So click here. So here we see, here we have three scales: scale, ordinal, nominal. Scale is, that means here interval and ratio scale are put in the scale option, and ordinal, nominal are put in the different option. Now what is the measure scales of measurement of location? It is scale, ordinal, or nominal. It is nominal because here we assign the codes arbitrarily just to identify that, just to signify. Okay, so it is called nominal. Okay, so it's a nominal variable. So if I go to data view, you see that my second variable comes. First variable is my name of the respondent. Second is his location. Okay. Second his location. Then third variable is my age. I think age, yes, this one age. So you go to variable view, select, click. Suppose age is my name of the variable. So it's a numeric, no problem. So suppose I am explaining it, age of the respondent. Then we don't need to have we don't need to use this one because it's not a coding variable. Okay, we don't have given codes, which are real values. Okay, so I don't need to use this one. So what is the scales of measurement here? It will be scale. It comes under ratio scale. Ratio and interval scale are clubbed into scale only. Okay, so it is a scale. So this is the way we can create a design our database. The next one is sex of the respondent. So sex of the respondent, sex. So it's a numerical because we have given numerical codes. Okay, then sex of the respondent. Then values, because it's a it has codes, na? 0 for I think male, 1 for our female. Okay, so it's a nominal variable. Here I have given the codes just to identify. It does not have any particular order. The categories male or female does not have any particular order. So I just given the codes, numerical values to identify. So it's a nominal variable, right? Then education. Next variable is education. So numeric, okay, then education, then values. This is a categorical variable. Na? It has categories illiterate 1, primary 2, up to SSLC. So these are the categories. Here you can put these categories in values. So click here values. For 1, it is illiterate. For 2, it is primary. I'm moving with fast because I have to show some lot of things. Primary, then third, SSLC, 4 ACES, 5. These are the categories, graduate and above. These are the categories, right? So I have to put one by one. So click OK. Then what is the scales of measurement here? It is ordinal, nominal, or scale. It is a ordinal variable because the categories are in a particular order, right from the lower education to higher education, illiterate, primary. So it is a ordinal variable. Okay. Now if I go to data view, you see these are the variables we have created. Now I have to enter the values here in the rows. Okay. In the first row, I have to enter all the information of the first person. In the second row, I have to enter all the information of the second person. In the third row, I have to enter all the information of the third person like this. Suppose name of the first person is suppose AAA. His location is from rural area, suppose. Okay. So rural means 0. His age is suppose 23 years. His sex is suppose 1, female. Then education is suppose 3, like this. So in this row, I have to enter all the information of the first person. In the second row, I have to enter all the information of the second variable like this. Okay. His age is suppose 14 years. His sex is 0. His education is 2, like this. Okay. So this way we have to enter the values. In the third row, this row, I have to enter the information of the third variable. Suppose, okay, then his location is suppose urban area. His age is suppose 42 years. Okay. Then his male, his education is 5, like this. Okay. So this way we have to create the database and enter the data. Okay. Now if I click here, this point, you see, if I click here, this point, this one, then the value levels will be shown. Okay. If I click here, you see the value levels are shown here. Okay. You see if I click this point, so you see if I click here, all the codes are shown. If I click again, then value levels are shown. This is very, very beneficial. Why these value levels are shown? Because we have given in the values, we have specified the categories here. That's why the value levels are shown here. And it will reduce the error of entering the data. Okay, during entering your data, you may commit some errors. But as the value levels are shown, these are the levels, this shown, it will reduce your error in entering the data. So it's a benefit of giving the saving the codes here. Okay. And it has 2 or 3 more benefits. I'll show you one by one. Okay. So this is the way we can enter our data, right? Okay. Now let us see the final database. So this is the final database. Okay. So this is the final database. I have entered the data like this. Okay. So I have 300. I have already told that my sample size is 300 on individuals. So I have to enter one by one all the 300 individuals. So you see, those are the 300 individuals. So this is the full database, whole database. Now after designing this database, we are ready for editing and analysis of the data. Okay. So I will show you some of the the ways of editing the data and analysis, right? Now, what type of analysis we have to do? So we have to do the analysis according to our objective, right? According to our objective, we have to analyze the data. So first is that type of analysis, descriptive statistics and inferential statistics. So first of all, we have to do a description of the data. Okay, so what type of data, how many males are there, how many females are there, what is the mean age of the persons, what is the so this type of analysis we have to first conducted. This type of analysis, I want to show you one of my latest recent papers. So it's my very recent paper. Okay, so actually this paper was done in collaboration with Zahaden University of Medical Sciences, Iran. Okay, so here what we did, we developed a instrument for evaluating the effectiveness of using mobile phone in healthcare in Iran. How a mobile phone can be effective in healthcare facilities in Iran. So we have studied this. My collaborators are from Zahaden University of Iran. Okay, so here we studied we developed a instrument for studying evaluating the impact of mobile use in health sciences. So whatever may be the objective, I want to show you that first of all, what we did, we do a descriptive analysis of the data. So you see, so I just want to show you that this is the demographic profile of the study subject. So we have given a descriptive information before going to our main objective. We have given a descriptive information of the data, right? So first of all, our objective is to give a descriptive information of our data set, of our data, of what type of data we have collected. Okay, so for that, what we have to do here, we have two type of variables, right? Discrete variable, one is continuous variable. So location is a discrete variable, age is a continuous variable, sex is a discrete variable, education is a discrete variable, type of work is a discrete variable, like this. So height is a continuous variable, systolic blood pressure is a continuous variable. So we have basically two types of variables is here. One is discrete, one is continuous. And for discrete variable, we have to go for different statistical analysis, this descriptive analysis, and for continuous variable, we have to do different descriptive analysis. Okay, so first of all, let us do descriptive analysis for, suppose, discrete variable. So what type of descriptive analysis we can do with discrete variables? We can do frequency tables, very simple. So we can go for frequency tables. Okay, suppose I want to know how many people, so I have 300 individuals from rural or urban area. Now I want to know how many individuals are from rural area, how many individuals from urban area. So for that, I have to go to analyze, very simple, descriptive statistics, then go to frequency. Okay, so this window comes. Here we have the list of the variables. You see the list of the variables. Suppose I want to know the number of person from rural area and urban area. So click it here, click this, click OK. You will get the frequency table. You see, this is the frequency table. Okay. So rural, how many people are from rural area? 228 people. 76% people are from rural area, and urban area 72 people. 24% people. That means out of every 100 people, 76% are from rural area and 24% are from urban area. So for making the projects or for making the reports, or then we have to put it in the, we have to copy it into the Word. No? So it can be very easily copied to Word. So I'll show you. So we are making our reports in Word. So we have to copy this. To copy this, it is very easy. Or we can copy it to Excel also. Just click it here, click copy. Okay. Then paste. It can be very easily copied to the Word, or you can this actually this is the frequency, this is percentage, this is valid percentage. Actually valid percentage is used when you have some missing values. Okay, in this case we don't have any missing value, so this is actually not necessary. These two columns are not necessary, so you can ignore it. Okay, no problem. Okay, so it is very easily converted to Word. Suppose I want to find the frequency table for all the categorical variables. So what are the categorical variables? Location, sex, education, type of work, extra-cell, family history. These are my categorical variables. So what I have to do, I have to go to analyze, descriptive statistics, frequency. I can put all the variable in one time. Okay, I can select all the variables in a single stroke. So you see all the variables come here. Okay, now you see it is written as rural and urban. Now why this is coming rural and urban? Because we have in the value, in the data view, in the values we have given the, we have saved the codes. That's why it is coming as rural and urban. If we don't save the codes, it will be coming as 0 and 1. This is one of the benefits of using the value option. Okay, so you can make different graphs from this also. You can make pie graphs. When you have only one variable, you can make pie graphs. So pie, summarize group of cases. So slice by, suppose I want to make a slice for 6. So click OK. So for making graphs, it is a process. It is under process. So I'll show you that step one more time. Graphs, legacy dialogues. Then you have to go to pie or bar. For one variable, you have to either use bar chart or pie chart. Okay. So you have to go to pie, click pie, then select this one, summaries for groups of cases. Okay. Then click define. Okay. Then you have to. This is the graph. So this is the portion for male. This is the portion for females. So it can be very easily done, right? Okay. Now, let us talk about continuous variables. So for discrete variable, we can make frequency table and graphs, or we can make cross tables also. I will show you how to make cross tables later. So it can be used to make frequency for describing. You see in my paper, these are all actually frequency tables. There are 45 males, 158 females. This is the percentage. These are all descriptive tables. Okay, so or we can make graphs. Okay, for discrete variables, for categorical variables, and we can make cross tables also. Okay, I'll show you cross table later. First of all, we will let us talk about descriptive statistics for continuous variable. Okay, now for continuous variable, what type of descriptive statistics we can use? For continuous variable, can we make frequency tables? We can make frequency table. If we in SPSS, we can make frequency table for continuous variable. I will show you. So same process, go to analyze, descriptive statistics, frequency. These are the previously given variables. So select all of them and put it here. So age, okay. Click. So this is the frequency table for age. You see, it's a big table. So there are 18 people. There are 17 people whose age is 18. There are 3 people whose age is 19. So there are 8 people whose age is 20 years. So this type of for frequency table, actually, for continuous variable, actually, this type of table is not feasible. Okay, it will give very less information to us, right? So what we do in continuous variables, we'll make class intervals. We'll make class intervals like this. Okay, so you see class intervals like this. So I will show you how to make class intervals in SPSS, right? So that means we can make frequency table just like categorical variables, but it will be a huge table. It will not give you fruitful information, right? So in continuous variable, when we have to make a frequency table, we'll make class intervals. Okay. Okay. This is a one way of presenting descriptive analysis of continuous variable. Okay. Now what we can also, for continuous variable, we can calculate the different measures of central tendency and dispersion. We can calculate the measure of central tendency and dispersion. So let us first, before constructing the frequency table, let us first try it for measure of central tendency and dispersion for the continuous variable. So first of all, I have to go to analyze, then descriptive statistics, then frequency. Okay, then select age. Suppose this is the variable for which I want to calculate the mean, median, mode, all the measures of central tendency and dispersion. I select this one here, put it here, then click statistics, then click all the measures I need: mean, median, mode, standard deviation, variance, skewness, kurtosis, quartiles, anything you need, you can click it here, click continue, click OK. You see, this is the values. So mean age is 40.99 years, median age is 38 years, mode age is 18, standard deviation is this, variance is this, skewness, kurtosis, everything we got it in seconds. Right? Okay. So if I want to calculate for all the continuous variable in a single time simultaneously, then I have to go to same way, the descriptive statistics, frequency, put all the continuous variable. Height is a continuous variable. Weight, height, systolic blood pressure, diastolic blood pressure. Okay. You see, we have calculated for all the variables. So what is the mean systolic blood pressure? This is the mean systolic blood pressure. The median systolic blood pressure is this one. So it's very easy. Okay. So this is the way calculating the descriptive statistics for continuous variables. Okay. Now, also one thing. Suppose let us calculate it for only systolic blood pressure. Okay. Suppose my mean systolic blood pressure is 120.42. Okay. Mean systolic blood pressure of is 120.42. Now this 124 mean is calculated from 300 individuals. 300 individuals. Suppose this 300 individual includes both male and females. Suppose I want to calculate the mean systolic blood pressure for male and female separately. Okay, I want to calculate it for male and female separately. So how it can be done? Okay, so I'll show you how we can calculate the means for different groups, different clusters, for sections. Okay, so we can do it by using two ways. One is we can use data option, and in analysis also we can do it. First of all, I'll show you in data option. Okay, so in data there is an option called select cases. Okay, by using this select cases option, we can select a particular section of the data. Okay, we can, if I give some logical statement, and I can select a particular section of the data. Okay, so if I go to select a particular section of the data, this option is very much used while analyzing your data. Okay, that's why I'm showing you. Suppose I want to select cases, I want to select only a section of the data, not all the data. Okay, so for that I have to go to select cases. You see, select cases, there is now it is all cases are selected. You see, select all cases. Now I want to calculate the mean for only males. That means only male. What is the mean systolic blood pressure for males? So I have to select only the males, not the females. So I want to ignore the females. Okay, I want to ignore the females. I want to select only the males. Then in that case, I have to put a condition here. Okay, I have to put a condition. Now it is all the cases are selected now. So I want to put a condition so that the males are only selected. Females are ignored from the analysis. So I have to click here, if condition satisfied. Now only those cases will be selected which satisfies this condition, right? So click if. I have to put a condition here. So in this place, I have to put a condition. So sex. So I want to select only male. No? So male means 0. So select cases if sex equal to 0. This is my condition. So select, you see here, select cases if sex is 0. That means males. That means I will select only males. Click OK. You see, if you go to the database, you see the first person is a female. So it is out of the analysis, ignored from the analysis. The ninth person is a male. So it is in the analysis. So here females are ignored and males are only. Now if I calculate the mean, males, the mean will be for males only. Females are out of the analysis. Okay. From this row, you see this diagonal, it shows that females are ignored. So you go to analyze, descriptive statistics, frequency. Now systolic blood pressure, you see the total number is now 142. That means we have 142 males and mean is 112.52. Okay, so mean systolic blood pressure is 122.52. So this is the systolic blood pressure for male. Now we have to put the systolic blood pressure for females. Then we have to select only the females. So go to select cases. If condition satisfied, now we have to make it female. Females means 1. Okay, continue. Okay, you see. Let us do one more time. The computer is too slow. So you see, now females are selected, males are out of the analysis, right? Now go to analyze, descriptive statistics, frequency, systolic blood pressure. This is the 158. So total males are 142 and females are 158, total 300. So mean systolic blood pressure is 118.53. Okay. So this, by using the select option, we can select a particular section of the people and we can calculate it very easily. Suppose if you want to analyze the NFSS data, in NFSS data we have information on all the states. Okay, so suppose you want to select only the Assam data. So by using select option, you can very easily select only a particular section of the people. Okay, by giving this if options, you have to give a condition here. Okay, according to the condition, SPSS will select that particular section of the people, right? Now for calculating the means, I can, for calculating the means for male and female separately, we can use one more option, that is analyze, compare means. Okay, so go to mean. Okay, then dependent our systolic blood pressure. Okay, independent sex. Dependent variable is the systolic blood pressure and independent variable is sex. So I can choose the different options. So mean, if I want to here, these are the statistics that it is going to be calculated. Suppose I want some more statistics to be calculated, then I have to select from here to put it here. So median, if I want to calculate the median also, click it here and put it here. Continue. Okay. You see? So male mean is 122.52, female is 118. So now can we from here, can we say that males are more, you see males are more hypertensive. Male systolic blood pressure is more than females. Now can we say that males are more hypertensive than female from this table? This table shows that the mean systolic blood pressure of male is more than female. It is for male it is 122, for female is 118. Okay, can we say that males are more hypertensive from this? This is to this table is true for only 300 individuals for the sample. Okay. Now to check it whether this is true for the whole population or not, we have to apply some statistical test. That is the main purpose of statistics. The main purpose of statistics is to generalize the thing. That the thing that you got from sample, you have to test it whether this is also true for whole population or not. The main purpose of statistics is to generalize the results for the whole population. Okay. So today we cannot talk about the parametric test because time is not there. Okay. Then now I will show you how to make frequency table like this. Okay. For constructing frequency table, I will use a option. It is in transform called recode variable. This is also very important for analyzing your data. Okay, you frequently have to use recode option for editing of the data. Okay, that's why I'm showing you how to recode the variables. It is very important. Okay, so to construct frequency table, okay, what information we need? First of all, what information we need? You see, it is started from 60. That means before 60, no values are there. And it ends in 99. So after 99, there is no values. That's why it started from 60 and ends in 99. That means before 60, you cannot start the, the frequency class interval right from 0 to 10. If I make the frequency table for these values from 0 to 10, 10 to 20 like this, then frequencies will be 0. There is no values having 10, 10, 12 like this. So it's the values are starting from 60. So they have constructed the frequency table from 60. So that's the same way. We will also have to check our minimum value and the maximum value from where I have to construct the frequency table and where I have to end it. Okay. So go to analyze to show the frequency table. To know the maximum value and minimum value, I have to go to frequency. So let us make a frequency table for age category. This I am going to make a frequency table for age category, right? So go to analyze. First of all, I have to check what is the minimum value and what is the maximum value so that we can make the frequency table very easily. Okay. So frequency. So put age. Okay. So statistics, I don't need mean, median like this. I need only minimum value and maximum value. Select minimum, maximum. Okay, click continue. So my minimum value is 18. Okay, so maximum value is 87, right? So minimum is 18. Let me write it. Minimum is 18 and maximum is 87, right? Okay, now we have to start it from 18. Right? We have to start it from 18 and ends up in 87. Now, next thing we have to do is to calculate the range of the value. Range means maximum value minus minimum value. We have to calculate the range. Let us use Excel for that. Okay. So, minimum value is 8, maximum value is 87, minimum value is 18. So what is the range? Range is 87 minus this. So it is 69. Okay. So 69 is now for constructing the frequency table. I have to decide one thing. There are two things. One is length of the class interval or number of classes. Okay. We have to decide either one of these. I have to decide how many number of classes I am going to take or length of the class interval. Okay. Suppose I want to construct a frequency table for 5 classes. I will take 5 class intervals. Okay. So what we have to do, I have to divide 69 by 5. Okay. So it will be 13.8. So that will be my class length, width of the class. It will be approximately considered as 14. Okay, so let us make the class interval here only. So it will be 18. First lower limit is 18. So it is, suppose this is upper limit, it is lower limit. Let us make it here only. Okay, then we will put it in SPSS. This is the upper value. So minimum value is 18. So maximum value is will be what? 18 plus 14. 14 is the length of the class now. So maximum value is 32. So then 32, okay, equal to 32 plus 14. This is the second class interval. Then 46 equal to 46 plus 14. Okay. Then 60 equal to 60 plus 14. 74. Okay. Then 74 equal to 74 plus 14. Okay. So this is my class interval, right? But there is a problem here. Suppose one person, his age is 32 years. So in which group we are going to put it? In this group or this group? This group or this group? We have to put it in this group because this is an exclusive class interval. Okay, this is actually not 32, right? This is actually 31.999, just before 32. We have to give this like this in SPSS. Otherwise, SPSS will not. There will be a lot of missing values. Okay, then this is not 45. It's 46. This is 45.999. This is 59.999. Then this is 73.999, and this is 87.99 or 88. The last is not problem. So you understand, I think. So because this is an exclusive class interval, we have to exclude the last value here. Okay, that means it will take values from 18 to 30. The boundary is this. But this, as it is an exclusive class interval, we have to exclude the last value. That means 32. We can take value up to 31.999. Okay. So let me write here. So these are my categories: 31.999, then 32 to 45.999, then 46, 59.999, 60 to 73.999. Then 74 to 88. Okay, so these are the class interval. Now I will make class interval like this. Okay, now in SPSS we have, we have actually a option called transform. Here we have two things. One is recode into same variable and recode into different variable. If I use the first option, recode into same variable, what will happen? This original value will be discarded and recoded will be done here. Okay. One more thing I want to tell you. Actually, in calculating this, what we do, we converting the continuous variable to a ordinal variable. Actually, this is a continuous variable. Now we are going to make a code here. We have to put it in class interval. So what we have to do, we have to suppose it will be like this. Suppose what we will do, this first category, this become a categorical. Now this become category. This is the first category, this is the second category, this is the third category, this is the fourth category. It becomes category. So let us have to code this category. Suppose this is the first category, I have put it 1, then this is the second category, I put 2, this is the third category, I put 3. So this is the fourth category. These are the now it becomes a categorical variables. Originally it is a continuous variable. Now as I make this as a in class intervals, so I put it is a categorical variable. So I have to give code like this. So for this first category, this is I put this category as 1. Second variable I put this as category 2. Third variable the category is 3, like this. So I have to put like this. Okay. So actually, what are in making class intervals? What are we are doing? We are converting the continuous variable to categorical variable. Okay. So you see 60, na 60. 60. This is 4. Okay. So you see, if I use the first option, if I go to transform and recording, if I use the record into same variable, then the original value will be recorded. This become 4. Okay, why it is 4? Because you see 60 to 73.99 is coded as 4. It becomes 4. Second one becomes, it becomes 1, like this. So original data will be gone. That will not be a good thing. So what we'll do, we are going to use the second option, recorded into different variables. Okay, actually what we are doing, we are recoding the values. We are recording the values into categories here. Okay, so go to transform, record. You see a window comes here. We have you have seen that we have two options. One is input variable, one is output variable. So I have to first put the input variable. So what is input variable? Input variable is my age. Now you see here a question mark. So I have to give the name of the output variable. So what we're going to do, if I would use this option, record into different variable. So what if I use this option, then what will happen? A new variable will be created. Okay, which gives us the codes. 18 to 23, it's 1. The code will be given by the new variable. So if I use the second option, a new variable created at the last, right? So let us calculate the new variables. So transform, record into different variables. Okay, so put age here, then output variable. So suppose I age code, the new, I have to give the name of the new variable, age code. I have to give underscore because I cannot put blank spaces. I have to follow the same rule. Okay, satisfied by SPSS. So click on change. Now the original variable was age. Now a new variable will be created with the name of age code. Okay, then I have to click old and new values, right? Now it is very easy. This window comes. Now you see there are two sections of this window. First section, this is the section. This is a one part and this is the second part. This part is for the old values. Here I have to provide the old values and here I have to provide the new values, right? In this section I have to put the old values. In this section I have to put the new values. This option is very, very important. I'll show how it can be used in another example. Okay, now this section is for if I want to transform categorical variables, and if I want to transform continuous variable, then I have to use this option range. Okay, I have to use this option range to convert to recode continuous variable. So this is, as age is a continuous variable, so I have to use range. Okay, so click here. So I have to put the first range 18 to 31.99 as we have already calculated in SPSS. This is the first class. So in the new value, I have given it as 1. We have already given the codes in Excel file. Okay, so click add. Now you see 18 to 31.99, it will be coded as 1. Okay, then 32 to 45.99, it is coded as 2. You see here. Then 46 to 59.99 is coded as 3. And then 60 to 73.99 is coded as 4. Okay, then 74 to 88, it is coded as 5. So these are the codings. Now a new variable will be created at the last. You see, if I go to the last of the database, you see this is the age code. 4 means the first person is 60 years, na? 60 years. His age is 60. You see, it will be coded as 4. You see, this is 4. If I go to the Excel, you see 60 means 4. 60 to 73, people are converted as 4. Okay. Okay. So this is the coding variable. Now, if I go to variable view, and now if I want to make the frequency table, so go to analyze descriptive statistics frequency. Okay. Then go to age code. So this is the frequency table. 1, there are 119 people. 1 means 18 to 39. There are how many people? 119 people. 2 to 63 people. 2 means 32 to 46. There are how many people? 63 people. Okay, now it is, these categories are coming in codes. So to avoid this, what we have to do, we have to put the value levels. Okay, so I have to use this. You see, use this. 1 means 18 to 32. 2 means 32 to 46. 3 means 46 to 60. 4 means 60 to 73. 5 means 70 not 3, this is 74. 70 change. Okay, 4 to, now 4 is 60 to 74. 5 will be 75, 74 and above. 74 and above. Okay, click add. Now as I have given the value levels here, you see, if I make the frequency table, now is good. This is the one of the advantage of giving the value levels. You see, now it is very easy for us to identify the things. There are 119 people in the age category 18 to 32 years, 63 people in the age category 30 to 46 years, 66 people like this. So it will be, this is the way you can make frequency table in SPSS. Okay. Now for social science people, categorical data analysis is very important. So how to do cross tables. Okay, you see this table, this is a called a one-way table. Here we have only category, we have only rows. In illiterate there are 3 illiterate people, 92 primary people, 153. This is the frequency table for education. So this is the one-way table. Okay, now we can make this type of table also. It's called two-way table. It has both rows and columns. You see, if there are 3 people illiterate, out of this 1 is male, 2 is female. This type of table is very, very informative in analyzing categorical data. Okay, so here we have both males and females. So this is also called two-way table. We call it contingency table. We call it cross tables. Okay, so it has a lot of names. So I'll show you how to make cross tables, right? Before that, suppose my prime objective is to find how many people prevalence of hypertension. My study is to find prevalence of hypertension. So I'll show you how to calculate the prevalence of hypertension. So I am not, because time is not there, I'm not going to use both systolic and diastolic blood pressure. I'm using doing my calculation with only systolic blood pressure. Okay, suppose I want to know how many people are infected from the disease. Here in the data we have the original readings. So first person reading is 114, second one is 120, third person is 111, fourth person is 1. From this I have to identify the people who are infected from the disease, right? For that I have to follow the rules. So there are certain rules according to the World Health Organization. So I have written the rules here. A person is called hypertensive if his systolic blood pressure is more than 140, more than or equal to 140, then he is called hypertensive. So I have to use this rule to identify the person according to the whether he is hypertensive or not. Okay, but it is not possible to observe all the person like this one by one. Okay, so what I'm going to do, I'm going to create one variable here in the last, which shows us whether the person is hypertensive or non-normal. Okay, so here you see this first person, his systolic blood pressure is 114. That means he is less than 140. That means he is a normal people. Second one is 120. He is also normal, but I cannot observe one by one. Nah? So what I am going to do, I am going to create one variable here. which give us information that whether the person is normal or hypertensive. That means I have to create a binary variable, a variable with two categories, having categories no or yes. No means the person is normal, one means the person is having hypertension. So here what we are going to do, my basic objective is to create a, from this variable I am going to create a binary variable. Binary means the variable having only two categories, that is called binary variable. So I am going to create a binary variables by using with the help of which I can identify which people are hypertensive. Okay, so for that I have to follow this rule. And this is the rule. Systolic blood pressure is more than equal to 140, then I have to use this. Okay, so for that, first of all, what I used to do, I first find the frequencies. Let us find the frequency for systolic blood pressure. Okay, you see, so lowest systolic blood pressure is 89. So this is the frequency. Okay, so there are 89 to one people whose systolic blood pressure is 89. Two people whose systolic blood pressure is 90. It is very now you see, if I use this one, you see, you see, here we can make two separate groups. You see, 138 and this less, these people are normal. From this 140 to the above, all these people are hypertensive. So we will classify the people into two groups. First group is called 0, second group is called 1. Okay. Okay, but we can do this by using the same recode option. Okay, so using the recode option, I have to use, so go to transform, recode the into same variable or recode into, if I use the same variable option, then this will be recorded, this becomes 0, this becomes 0, but we cannot afford to lose the original data. Okay, so that's why we are using the second option, recode into different variables. Okay, so this is the previous one. So systolic blood pressure, the input variable is systolic blood pressure. So output variable is, suppose SBP code. Suppose I have given a name, is any name. Okay, click on change. So original variable is systolic blood pressure, and diastolic, the new variable is SBP code. So I have to put the old and new values. Okay, so select this. These are the previous values. So I have to remove this. Okay, so I'll make two categories. So range. So lowest value, first category is for normal people. Suppose, so my normal lowest value is 89, na 88. Suppose 88. Okay, so to 88 to 139.99. So 140 means he is having pressure. Okay, 88 to 130. 88 is I think my last value is 89. That's why I'm putting 88. 88 to 139.99 equal to new value will be 0. Okay, then 140, or we can give like this also, 140. This we can use this option also. 140 throw highest. That means 142 above, all the values will be taken as 1. Okay, click here. Click OK. Continue. Okay, you see. You see, this is the new variable. So first variable is 144 0 normal. Second is normal. Third person is normal. Fourth person is normal. So it is, you see, this person is having 140. Is now it will be very easy for me to identify which people are infected from the disease and which people are not infected from the disease. The same process we can do it for diastolic blood pressure also. I'll show you how to do it in diastolic blood pressure. No, let us do it for, because time is not there, for systolic blood pressure. Okay, now go to variable view. Now if I go to analyze descriptive statistics, SBP code. Okay, you see 0 means 267. We have March sample size is 300. Out of that, 267 people are infected, are normal. They don't have the disease. And how many people are hypertensive? 33 people are hypertensive. Okay. So it is coming at 0 and 1. Na? So people may ask you what is 0, what is 1. Okay. For that, what you have to do, you have to go to variable view and click on values and put the codings. 0 means no, 1 means yes, yes or hypertensive. Or we can put like this also. 0 means normal, normal. 1 means hypertensive. Okay. Change. Oh, sorry. 0 for normal. 1 for hypertensive. Okay. Click OK. Now, if I calculate this, this is one of my objective. So, how many people are infected from the disease? You know, 11 people out of every 100 people are infected from the disease in my study area. Okay. Every 11 people out of 100 people, because my percentage is a very, very important measure in statistical calculations. Okay. So I'll show you what is the advantages of using percentage. So percentage is a very, very important measure that you see that out of every 100 people, 11 people are infected from the disease. So what is the prevalence? Prevalence is 11 out of 100. Okay. Now I will make, suppose, now I want to make frequency tables, two-way tables. So it is a, the table I have already constructed is a one-way table. Okay. One-way table. This is a one-way table. It has only rows, normal and hypertensive. Now I want to need a breakup. Suppose we have 33 people are infected from the disease. I want to know out of these 33 people, how many are males, how many are females. So for that, I need to break up this thing. And for that, I need to use contingency table or cross tables, right? Okay, so for that, I have to go to analyze. So I'll make a cross table like this. This one. This is a two-way table or cross table. It has rows and columns. I have to put a column and I have to put rows. Okay. So for that, I have to go to analyze, descriptive statistics, cross tabs. Okay. Also one more time, analyze, descriptive statistics, cross tabs. Okay. Then you see here we have to specify the rows and columns. Okay. So let us put SBP code as in columns. Okay, you can put it in rows also, no problem. But I prefer to put the variable, my study variable into columns. That will be easier for me. I find it easier to interpret the values if I put my original study variable in columns. I always used to put my study variable. Here my study variable is, the main variable is my systolic blood pressure, and the age or sex. These are my auxiliary variables. Okay, these are factors which may influence hypertension, right? So I used to put systolic blood, the study variable in columns. Okay, then suppose I need the sex-wise breakup. So click sex in rows, click OK. Okay, this is the table. Okay. Now, can we say which group is more infected from the disease? There are how many males? 22 males are infected from the disease and 11 females are infected from the disease. From this table, can you say which group is more infected from the disease? Or we can make it first. Look, suppose I want to know the this pattern, hypertensive pattern, with respect to location also. So suppose go to analyze, descriptive statistics, cross tabs. Okay, then go to location. This is the residency status. Okay, then now you, from this table it is very clear Now you see in the rural area, there are 24 people are infected from the disease. And in urban area, only 9 people are infected from the disease. Okay. Now, can you tell me which group is more infected from the disease? Urban or rural? And here in the first table, male or female, which group is more infected from the disease? Okay. I think most of you say that rural people are more infected because the number is high. Because this is not like this. Because you see 24 people are infected from the disease is among 228 people. Okay, this 24 figure is coming from 228 people, and urban people are only 72. Out of that, 9 people are infected from the disease. So it will be very difficult for us to tell which group is more infected from the disease. Okay, because the total number of cases is not same. In one case, the total number of cases is 228. In the second case, the total number of cases is 27. If both the total number of cases is same, then it will be very easier for us to tell which group is more infected from the disease. So that's why we have to use percentage. Percentage make them equal. Percentage make them 100. So if I calculate the percentage, then it will become out of 100. This will become a real. We'll get the number of person who are infected from the disease out of 100. For urban also, we'll get the number of person who are infected from the disease out of 100, right? So it will be, if I have the total number of figures is same for both the groups, then it will be easier for us to tell. So let us calculate the percentage. So go to analyze descriptive statistics, the same process, cross tabs, right? Okay, click here, then go to sales. Okay, then you see we can use the percentage option, row or column percentage. So you can give row percentage also, you can give column percentage also. I prefer to give row percentage because when I give the study variable in columns and the auxiliary variable in rows, then it will be easier for me it is my personal opinion. It is easier for me to analyze, interpret the result if I give row percentage. So let us first give row percentage. Okay, continue. You see now the percentage is calculated row wise like this, like this. Percentage is calculated row wise like this and like this, right? So you see, so here while calculating the percentages for rural and urban area separately. So for rural area, so how many out of 100 people, how many people are infected from the disease? 10 people. Okay. From urban area, how many people are infected from the disease? 12.5 people. Now from the original figure, you can see that more people from the rural area are infected from the disease. But if we convert it into percentage, you can see a reverse picture. You see that out of 100 people in the urban area, 12.5 people, about 13 people out of 100 people are infected from the disease. And in the rural area, about 11 people are infected from the disease. So percentage give us lot of information. Okay, percentage is a very good measure in epidemiology. We have a subject called epidemiology. It studies the health condition, and statistics has a lot of importance in epidemiology. In our university, we have a special paper on epidemiology. So in epidemiology also, most of the calculation are based on percentages, okay, and chi-square. So now from this table, you see that urban people are more infected from the disease, okay, because out of every 100 people, 13 people are infected from the disease, and in rural area only 11 people are infected from the disease. Can we tell from this that urban people are more prone to the disease, whether urban people is more infected from the disease? Okay, that so from this actually we cannot tell it for the whole population. Okay, for that we have to use statistical test. We have to generalize this. This is all this observation is based on only only 300 individuals. We don't know what will be the actual picture in the whole population. For studying the whole population, we have to go for statistical test. And in this case, we are going to use chi-square test of independence of attributes. Independence of attribute means here we have two attributes. One is location, one is hypertension. I want to check that both the attributes are independent. It does not matter whether a person is coming from rural area or urban area, his chances of having hypertension will be same. Okay, it does not matter whether he is from rural area or urban area. So that is why it is called chi-square test for independence of attribute, right? Now for that, I have to go for chi-square test. When we have two categorical variables, then I have to go for chi-square test. All right. For using chi-square test, I have to consider a null hypothesis. Now, for doing any hypothesis test, I have to use a null hypothesis. So what will be my null hypothesis? Null hypothesis means hypothesis of no difference, right? So what we have to do, we have to consider that no difference. That means whether this person is coming from rural area or urban area, it does not matter. He may be here. He is having the same, he's experiencing the same risk of having hypertension. Whether he's coming from rural area or urban area, it does not matter. The person is experiencing the same risk of hypertension. That means there is no relationship between location and hypertension. Okay, so for that, so my null hypothesis will be there is no relationship between location and hypertension. So for that, I have to go to analyze descriptive statistics, same procedure, cross steps. Okay, then it is already there, location, and then I have to go to statistics, go to chi-square. Okay, here we can, you see here one option is there, risk. This is also a very important measure in epidemiology. Here we calculate the risk of developing the disease among a particular group. Okay, this can be calculated by using logistic regression also for calculating the risk. Here, this risk is actually called odds ratio. Okay, this is a very important measure in epidemiology. It will help us to know. Suppose I want to know what is the risk of a person who is a smoker of developing hypertension. So we can calculate it by using this risk option, the risk of developing the disease among smokers. Okay, so this type of measures can be calculated by using chi-square, this risk option. This is called actually odds ratio relative risk. We have different measures for risks, calculating the risk of disease. Okay, so go to chi-square, continue, click OK. So this is the table we already got, and this is the Pearson chi-square test. This one. Okay, so this is the chi-square value 218. 218 is the chi-square value, and this is the p-value. P-value is 0.641. So p-value is greater than 0.05, right? This p-value is greater than 0.05. So I think everybody knows this thing. If I want to accept or reject an null hypothesis based on p-value, then I have to follow the rule that if the p-value is less than 0.05, that means 95. If I consider 95% significance level, that means if it is less than 0.05, then we reject the null hypothesis. If this is greater than 0.05, then we have to accept the null hypothesis. So here we see that it is more than 0.05. That means we have to accept the null hypothesis that there is no difference. That means the results shown in this table, that males, urban people are more infected from the disease, is not true in the whole population. Okay, there is no relationship between location and systolic blood pressure. Okay, so as the p-value is greater than 0.05, that means we have to check that there is no relationship between, that means we have to accept the null hypothesis. It is 0.05, more than 0.05, that means we have to accept the null hypothesis. What is the null hypothesis? That there is no relationship between location and hypertension. Okay, so we accept the null hypothesis that whether a person is coming from rural area or urban area, there is no difference. Both the people are experiencing the same risks of developing the disease, right? So we can calculate it for other variables also. Suppose I want to know whether taking extra salt is is a risk factor for the disease. I want to know whether taking extra salt is the person who are taking extra salt is experiencing more risk than the person who is not taking extra salt of developing hypertension. So our null hypothesis will be that there is no relationship between extra salt and hypertension. So for that I have to go to analyze, cross steps, then select extra salt, continue. Okay, here also you see that it is more than 0.05. So it means that both the groups are not related. Actually, this data the data I have taken. This data is from an original data. The original sample size was actually 12,313. I have taken only 300 individuals. That's why results are coming like this. Okay, if I take all the values, then the result may be different. Actually, 300 is not the actual sample size. If you don't have the actual sample size, you have calculated from the sample size calculating formula, then your results will not be fruitful. Okay, so you always keep in mind about taking a proper sample size and proper sampling technique. Okay. Now, hello, Baido.
Hello.
I think time is over. Actually, we don't have any end to the SPSS. It's a lot of options are available. So
Yes, you can carry on,
okay,
Dr. Burman.
okay.
You can carry on. You can finish it off.
No, I actually, if I start a new thing, that it will take a lot of time. Actually,
No need to start a new thing. You can wind up because there's question answer session also.
okay. That's why I'm telling you.
Okay.
So I think I should stop here because
Okay.
if I start a new thing, it will take a lot of time.
Okay.
Thank you for patient.
Thank you very much, Dr. Burman, for your elaborate and lucid explanation on how to go about the various steps in creating a database in SPSS and how to analyze the data. You have dealt with cross tables or contingency tables, which are very much used in social science research, and chi-square test is also very much used in research, social science research. So later on, if we have another occasion, we can deal with other tests also. So thank you very much. I think most of our participants will be benefited by today's deliberations. And then those who are new to SPSS, they are extremely benefited because you have touched so many things and about recoding of the variables, and I really went back to my research days hearing your deliberations. Thank you very much. Now, there are many questions popping out in the chat box. So may I request Santanu Bora, Assistant Professor, Department of Mathematics and Statistics, to coordinate the question answer session. Before that, I want to inform the participants that the feedback provided in the chat box towards the end of the program. You are requested to fill it up properly for receiving your e-certificate. Over to Santanu.
Hello everyone, good evening. Good evening everyone. Due to network problems, I have to stop my video. Some questions are there. Good evening sir. Few questions are there for you. First question from Sanjay Hazarika. Explain the formula. Explain the formula of sample size calculations. Explain the formula of sample size calculations. Do you hear me? Hello?
We don't have a specific formula for sample size calculation. For different situations, we have different formulas. Okay, so suppose I want to calculate the prevalence of a disease. I want to know how does the prevalence. For that, I have to use some different formula. Suppose I want to know the mean of systolic blood pressure for a particular people. So I have to use different formulas. So you have different formulas for different type of studies also. Okay, I use cross-sectional studies, I have to use different formula. If I use cross-sectional there is not a specific formula for sample size. You have to use different formula according to your objective, according to your situations. You have to apply different formulas for sample size calculation. That will be a different topic for lecture actually.
Okay. Okay, sir. Thank you. Next questions. Can we use GLM for qualitative data? Can we use GLM for qualitative data?
For conducting GLM, I think it is not appropriate for qualitative data. For qualitative data, you can use logistic regression. I think it will be better. For GLM, I think it is not appropriate to use qualitative data. Actually, we have to see the your data also to give the proper answer. Okay.
Okay. The next questions from Manish. Codes can be only numerical or can it be alphabet?
Okay, you see, if it is alphabetical, then we cannot apply statistical methods. A statistical method is means for only numerical data, na? So actually, R.A. Fisher is called the father of statistics. He defines statistics as the applied branch of mathematics. Okay, so here we cannot use statistical methods are not mean for using alphabetical data. So I have to make it numeric for using statistical methods.
Thank you, sir. Next question from Akansa. What are the benefits of coding 0 and 1? What are the benefits of coding 0 and 1?
Actually, the main actually, if I use advanced statistical method like logistic regression, then if I use code 0 and 1, that will be benefits. And actually, it will be difficult for me to tell you. I can show you how we can use 0 and 1 in different situations. Actually, if I use 0 and 1, then it will be very beneficial for us. Actually, it will take some time if I want to show you how to use how it can help us to use 0 and 1.
Thank you, sir. Next questions from Dr. Sayanika. What kind of editing to be made in the data set before initiating analysis?
Suppose
What kind of editing to be made in the
basically editings are done in codings. Suppose I want to do a class intervals. Our original data, raw data is in suppose I have already shown you how to make codings now by use it. Suppose I have coded the I have the systolic blood pressure for individual person. I have coded it to 0 and 1. That is a way of coding. Okay, that is not a part of analysis. Okay, for that coded values are used to analyze the results. Okay, so we have the raw data. We need to code it in a proper way for doing our further analysis. There are a lot of coding ways are available, but it will not. It will have. It will take a lot of time to show all the coding process.
Okay, thank you, sir. The next question from Diluar Hawk. Are rows representative of variables or respondents?
Pardon?
Are rows representative of variables or respondents?
I don't understand the question.
No, that both were of different pages.
The next question is from Tulika. Yes, ma'am. Next question is from Tulika Day. SPSS packages are very expensive and its trial versions also. If we download once, then it cannot be done later for second time. So, is there a way to use the free versions repeatedly?
Actually, cracked versions are also available. I am also using cracked versions actually. Cracked versions. If you so that I can I have 20 versions and I can show you give you a video how to install the 20 version crack by using the crack option. If you use that option, then it will be installed forever in your computer. Okay, so I think some of the computer shops also give SPSS. In Dibrugarh, we have some computer shops give SPSS when you purchase computers. So if I got the correct version, you can install it in your computer.
Okay, thank you, sir. The next question is from Sanjay. If the respondents are from a homogeneous source, then what is the minimum number of samples to be taken for PhD thesis?
Actually, that will be depend on your objective of the survey and what situation. Objective is the main thing. Suppose you want to calculate if you want to compare the two groups, then you have to apply some other method. If you want to find the prevalence of something, you have to use different method. If you have suppose infinite number of population, then you have a different formula, and it will be based on the objective and the situations. Okay. Next question.
Next question from Laya. How to enter data on multiple response? How to enter data on multiple response?
Actually, for multiple actions response, we have to enter. We can enter in two ways. Suppose I usually I have entered. Suppose let us share the skins. Suppose I have a multiple response 1, 2, 3, 4. So I used to enter the data in two ways. That will be helpful for me. Suppose a person gives response as 2, 3. So I entered as 2 and 3. And also I entered create two variables. One is for 2 and another is for 3, like this. So I entered in both the ways. Next.
Okay, so next questions. Can we use this software in keeping and analyzing the informations regarding business data in general?
Yes, it's very, you can use it very easily in business. Excel, you can use Excel also. In
Okay.
Excel, there are a lot of options of statistical analysis are available. I prefer to use Excel only. But for advanced statistical method, actually, Excel is not proper, but for basic statistical method, Excel is very, very good. For conducting test, F-test, regression analysis, this can be done very easily in Excel.
Okay, so next questions. Can you give a brief explanations about testing reliability of a questionnaire?
Okay, testing reliability of a questionnaire. Suppose I don't have the data for that. Suppose actually what I did a survey on suppose I did a suppose I have some questions, right? Suppose I one while I am doing PhD thesis, I did a survey quality of life study on cancer patients. So I have some questions. Suppose whether you have feeling pain. Okay, so for, I did the survey for survival quality of life of esophagus cancer patients. So I have some questions. Suppose, do you feel pain, or do you have any trouble in sleeping, like this? Suppose in one question, the cancer patient said that I feel very much pain, and in the second question he said that I have no problem in sleeping. Then both the questions are contradictory. These are not consistent. Reliability means consistency, right? So if the results, if the responses given by the person is not consistent, then we can call it not reliable. Okay, for calculating the reliability, we have different statistical measures are there. In SPSS, by using SPSS,
Okay,
we
sir.
can also calculate. I'll show you the one method, but I don't have the data right now. I'll show you.
Okay.
1 minute.
Last question.
1 minute. Go
Okay.
to analyze, scale, reliability analysis. Here we have a measure called Cronbach alpha. By using Cronbach alpha, you can do the reliability testing. But reliability means consistency, right? How consistent the person is while giving your answers. If this is not consistent, his results are not consistent, then your questionnaire is not reliable. Okay. So by using Cronbach alpha, this is the, if I want to give the variables questions here, put it here, and Cronbach alpha, click OK. You will get the Cronbach alpha value. Okay, next.
Last questions. Okay. No question is there. Okay. Last questions, sir, from Juti. Is it that the bigger the sample size, the better for every case, or not necessarily?
The bigger the sample size, the bigger, the more fruitful
Better.
your, better is your result. Okay, thus
Okay.
the sample size formula you have used, that is the minimum sample size, right? The sample size formula you have calculated, but the sample size you have calculated
Okay.
by using sample size formula, that is the minimum sample size. You have to take that one. If you take more than that one, that will be more, that will be better. That will give more better result for you. Okay. So that's formula you use, that is the minimum sample size. Okay. Thank you.
Okay. One question. Another question is there, sir. Last questions. Uh, would you please explain the process of inserting data of balance sheet in SPSS collected from different companies to calculate ratio and analyze it?
Actually, I have done 2 or 3 study on industrial companies. So suppose one minute, I'm opening SPSS. So it can be done in Excel also. Suppose in the rows I have to give the companies. Suppose SBI, suppose HDFC. Okay, like this. HDFC. Suppose Geo, like this. And in the columns you have to give the values of the different parameters. Suppose closing balance. Okay, and then suppose I don't know the different parameters. Suppose liabilities, like this, and you have to put like this. You're getting my point? So here first value is closing balance of SBI. This is the closing balance of HDFC. This is the closing balance of Geo. This is the liabilities of SBI. This is the liabilities of uh, HDFC. This is the liability of Geo. You have to put like this, and that will be depend on your situation also. Okay, how you need the data, how you need, what is the your objective. Based on that, you have to enter the data. In this way, you can enter the data in SPSS also. Excel and SPSS are more or less similar.
Okay. Thank you, sir. No question is there because shortage of time. Over to Runjun ma'am.
Thank you, Santanu. Now we come to the end of our program. I request Jayashree Pathak, Assistant Professor, Department of Mathematics and Statistics, to offer a vote of thanks and wind up the session.
Good evening. We have come to the end of national webinar on application of SPSS in social science research. It is my privilege to have been asked to deliver a vote of thanks on this special occasion. At the very outset, I would like to thank our resource person, Dr. Manos Protim Bormon, who spared his valuable time to grace today's webinar. Thank you, sir, for enlightening us by your excellent presentation on SPSS application in social science research, which will surely help all research scholars in interpretation of their results. I would like to express my gratitude to our respected principal, sir, Dr. Rishikesh Borua, for his guidance and support in organizing this national webinar. Thank you, sir, for your presence and for delivering the inaugural speech. I thank Dr. Runjun Fukan, HOD of the Department of Mathematics and Statistics, for her meticulous planning, coordinating, and execution of the webinar. Thank you, ma'am, for your constant encouragement and valuable suggestions. I also offer my thanks to our department colleagues, Mr. Hantanu Kumar Bora and Dr. Sandana Goswami, for their sincerity and dedication, which helped us to organize this webinar successfully. I take this opportunity to thank our technical support, Mr. Tony Bayon and Mr. Opurbo Haloy, Department of Information Technology, for their constant help and support. I also thank all the participants for their active participations and cooperation. Without your support, it would have not been possible to conduct this webinar. I also thank those who are involved indirectly or directly in organizing this webinar. I wind up my vote of thanks with warm regards and gratitude. With this, we come to the end of this webinar. Thank you so much.
Thank you. Thank you so much.